Okay, so now we're going to begin expressing multiple coins as decimals, and then we'll start working up into mixed coins. But this one's just going to be multiple coins. So let's take a look at a penny. So a penny is worth, from our other video, we know that a penny is worth equal to 1/100th of a dollar, or we say 1 cent. A cent means hundredth, means it takes 100 of these to make $1. Well, what if we did this? What if we say we had, let's say, 5 pennies? Well, as a decimal, we now have 5 1/100ths or 5/100ths, and we write it like this. It is decimal point. We have no numbers in the tenths, a 0, just as a placeholder. We have 5 pennies. And then we write it like this. So it's 5 cents. Mathematically, this 5 is in the hundredths place, right? So this is hundredths. Not hundreds, it's got a TH S at the end. This is 5/100ths or 5 cents, okay? So I'm trying to make this relationship between coins and the decimal system, okay? Well, let's imagine this, okay? We can have, the largest number that we can have in any one place is a 9. But if we exceed 9, we have to move over a column, okay? So we have 9/100ths. Well, what happens when we have 10/100ths? So let me get rid of this writing. We are going to have, what if we had 10 pennies? We now have 10 pennies, right? So in math, like I said, I can't have any number larger than 9. So what I'm going to do is 10 pennies is now equal to, here's my decimal point, here's my tenths, here's my hundredths. This number here is now larger than 9, it's 10, right? So what I do is we now have to move over a column, right? We now have 1/10th of a dollar, or it also could be read as 10/100ths, because that's the place here, 10/100ths. Or if we just read this number, it's 1/10th. But as money, we call it 10 cents. So every time we surpass the 9 in that column, we have to move over a column to the next column to the left. So now we would express 10 pennies as a $, decimal point, 1, and a 0. Now we could also just for fun, just make some irrelevance here. Also know that this would be equal to 2 nickels, which is also equal to a dime. But this, and this is still equal to the same amount, meaning it is 10/100ths or 1/10th or 10 cents. Okay, makes sense? For example, let's take another one here. Let's take 6 nickels. Now, nickels are worth 5 cents, okay? So in the old method, we would write it as, each nickel is worth 5 cents, and you would write 5 cents, 5 cents, 5 cents, 5 cents. One more 5. And the old method, we would say that 5, 10, 15, 20, 25, 30. This would be equal to 30 cents. But once again, we're not going to refer to these coins as being whole numbers. They are actually representing portions of a dollar. So let's get rid of this. And I want to show you how we would express this as an algorithm or just a series of, it's an expression of how much money is here. We would now begin representing it like this mathematically. So this is 1 nickel, 2 nickels, 3 nickels, 4 nickels, 5 nickels, 6 nickels. All right. Now, if we isolated just the fives right here, right? That's still just counting by fives. So that's 5, 10, 15, 20, 25, 30. But these are hundreds, so these are 500s. So now we have 30 hundredths, right? 30 is way bigger than 9, right? So what we do is we express it as 0.30. And it would be called 30 hundredths or just 3 tenths, or in money, we call it 30 cents. Now, let me show you the algorithm for this as well. I use the word algorithm a lot. It's the series of steps that we use to solve math problems. And we're adding these together. So what I do is I take 5 plus 5 plus 5 plus 5 plus 5 plus 5, which is 30. And I only take the ones from that number. So the ones in 30 would be 0. And that 0 is going to be squished down there. The tens, that 3 in the tens, is going to be carried to the next column because I can't exceed 9. 30 is way bigger than 9. So now I go 3 plus 0 plus 0 plus 0 plus 0 plus 0 plus 0 is 3. And the trick with decimals is that you always keep your place values lined up. Your hundredths are in line, your tenths are in line, and always, always, always your decimals are in a line, and you always bring it straight down, which gives you the same answer of 0.30 or 30 cents. All right, let's do this. Let's try adding, clear all this, yes. Let's try, and this, once again, we're just going to stick with the same coin, repetitive adding, and then expressing it as a decimal. So we're going to take 3 quarters. Now, if we express this as whole numbers, we would say that it says this, 75 cents. But we're going to express it as a decimal. In that case, it is going to be 75 hundredths of a dollar. So we're going to write our decimal point. We're going to write the 7. We're going to write the 5. And we're going to put the decimal point in front. This is read as 75 cents or 75 hundredths in mathematics. Okay. Now, if we were to do this, like I said, algorithmically, and I'm going to write that word because you hear it so much, algorithm, like this, we would stack these numbers on top of each other. So we would say 25 cents, and the rule for this is always line up your place values and always line up your decimal points. Decimal point 2, 5, decimal point 2, 5. We draw a line. Now I add 5 plus 5 is 10 plus 5 is 15. I only write the ones place from the sum that I get. I get a 5 here, 15 is bigger than 9, so now I'm going to take that tens place, which in this case is my 1, the 1 from the 15, carry it up here, because now that carries over. 3 nickels would be 15 cents, so I can't put that all in the hundreds, so now I have 1/10 plus all these 2/10. So I have 1/10 plus 2/10 is 3/10 plus 2 more tenths is 5/10 plus 2 more tenths is 7/10. So 1 plus 2 plus 2 plus 2 is 7. Always, always, always remember your decimal point. Bring your decimal point straight down, and you're left with 75 cents. Good, or 75 hundredths in mathematics. And so on, we can continue to do this with different amounts. Let's say that we were to exceed $1. Let's try that once. Why don't we say we have, let's say we have six quarters. Let me go ahead and start a new page here. I've got 6 quarters. Okay, like this. I've got 6 quarters. Now, the old method, once again, is I got 25 cents. 25 plus 25 is 50, plus 25 is 75, plus 25 is 100, plus 25 is 125, plus another 25 is 150 cents. That seems silly to refer to that way, but it's not 150 cents. It's 0.25 is a quarter, and I have 5 of those. So if I stack them like this, 0.25, 0.25, or 25 cents, or 25 hundredths, 0.25, 0.25, 0.25, and one more, 0.25. Let's do this algorithmically, right? So let's put our plus sign here, and here's our hundredths. Sorry, I didn't mean to really make that a 1. I'm just trying to make it so that you can see what I'm talking about here. There's your 5 back. So this column here is your hundredths. This column here is your tenths. And this time we're going to have to jump over the decimal point because we're going to have too many tenths that are going to fit into the tenth spot. So we have 5 hundredths plus 5 hundredths is 10 hundredths, 15 hundredths, 20 hundredths, 25 hundredths, 30 hundredths. We can't have more than 9 hundredths. So we're going to write the 0 from that 30 we just got, and we're going to move it to the next column because that gives us 3 tenths. Now we have 3 tenths plus 2 tenths is 5 tenths, 7 tenths, 9 tenths, 11 tenths, 13 tenths, 15 tenths. You can't have any more than 9. So in this case, 15 tenths, we're going to put the 5 here. And that 1 from the 15 is now going to become what? It's going to become a whole number. There's a whole column right here that exists, but currently we don't have any numbers in that column, and that's okay. We could technically just write in zeros here because that is the value of each one of those. And a lot of math, you do see the 0 point. So we have 1 plus all these zeros, which gives us a 1. Now, always, always, always bring your decimal point down, straight down. And this is now read as $1. Decimals are read as an and 50 is 50 cents. So that's $1.50. If we were to read this as a decimal, it would be 1 and 5 tenths or 1 and 50 hundredths. Okay, so let's go ahead and practice some of these repeated coin addition problems.